Let's practice using the equations of motion to describe the motion of various projectiles. Consider a stone dropped from a height of 10 meters above the ground. We will take downwards as positive. Acceleration is therefore positive. We will begin by sketching the graphs of acceleration, velocity, and position during these examples. You do not need to do this when solving a problem unless you are specifically asked to. It is, however, extremely useful to have a picture of what is going on to help you understand the question. The graph of the acceleration of the stone during the period of motion is shown. Acceleration remains constant at 9.8 meters per second squared downwards for the entire period. The stone is at rest before it is dropped. This means that the initial velocity is 0 meters per second. We will take the ground as the reference level. The initial position of the stone is therefore minus 10 meters, or 10 meters in the negative direction from the reference level. We can plot the initial and final positions of the stone on the position versus time graph. The stone is released 10 meters away from the reference level in the negative direction. When it strikes the ground at time tf, it has a position of 0 meters. We can sketch the graph of position versus time. This graph is always a parabola. We will learn more about the shapes of these graphs in a later lesson. We can use the equations of motion to answer the following questions. At what velocity does the stone strike the ground? This is the final velocity, since once the stone strikes the ground, it is no longer a projectile. We begin by making a sketch of the stone and listing the information we have. We can calculate the displacement of the stone for any time period by subtracting the final position from the initial position. This means that the stone moved 10 meters in the positive direction or 10 meters downwards. We now need to decide which of the equations of motion we can use to calculate the final velocity. Since we have A, Vi, and delta x, we will use this equation. Substitute the values into the equation. Simplify and solve for Vf. The value of Vf is positive, and the direction of Vf is therefore downwards. You must state the magnitude and direction of the velocity as your answer. We can now show the final velocity of the object on the velocity time graph. Velocity time graph is always a straight line graph. How long does the stone take to reach the ground? Once again, we must choose the appropriate equation of motion to use in our calculation. There are two equations which we are able to use, since we now have A, Vi, delta x, and Vf. We will do the calculation using both equations as an example. You only need to use one when solving a problem. Let's use this equation first. Substitute the values. Solve for delta t. Now let's use this equation. The advantage of this equation is that if for some reason you did not correctly calculate the final velocity of the stone, it will not affect the answer you get for delta t. Substitute the values. Solve for delta t. Since the initial time was 0, the final time is 1.43 seconds, and we can indicate this on the graphs. The sketches of the graphs showing the motion of the stone are now complete.